Hi guys, so today we're going to be looking at Chapter 5, Section 3, Graphing Radical Functions, Part 1. So, if we're going to graph radical functions, the main ones that you will see are the square root function and also the cubic root function. If we're going to graph out the square root function, we want to use numbers where we would end up with a whole number. So, for example, if I were to substitute x for 0, I know that x square root of 0 is equal to 0. I can use 1. Square root of 1 equals to 1. And I could use 4. Square root of 4 equals to 2. So from here, if I were to plot this out, I would get 0, 0, 1, 1, and 4, 2. And so you're going to see that my image is going to look more like a bended shape. It makes a little arc. And it starts at 0, 0. I can't go I can't make it negative because, again, remember that if I used x equals to -1, then I would get square root of -1, which is impossible. So it starts at 0 and it continues to go and increase higher up. For cubic root functions, it's a little different though. I can't just use certain numbers like 4, for example, because that doesn't work when it's cubic. So main numbers that I like to use are -8, because that gives me -2. -1, that equals to -1. Cubic root of 0 is just 0, cubic root of 1 is just 1, and then cubic root of 8 is, again, 2. And then from here, I'm just going to plot it out. And what you're going to see is that it curves up a little bit. So we get here 8 going all the way up to 2. It curves up a little. And let me just move this so it looks like it's curving up. And the other points are -1, -1, and -8 going all the way down to -2. And it curves downward as well. So kind of like this. And it increases going down. And so it looks kind of like a very flattened S, pretty much. Okay. And so we're going to be using these as our original functions. One thing that we are going to be looking at again is transforming radical functions instead. So if we're using transformations, again, horizontal translation that's moving left or right is going to be either in the inside of parentheses or, in this case, inside of the radical. And again, just a reminder that it goes the opposite way of what you expect it to do. So if it's x minus 7, you're shifting it to the right 7 points. Vertical translation up or down is going to be outside of the radical sign. So it's specifically going to be obvious. It's not like it's going to be over the line, but it will be outside of the radical of x. And if it's plus 7, that means you're moving up 7 points instead. A reflection over the x-axis will be a negative sign multiplying on the outside of your radical, and it will be the opposite way on the x-axis. So it's literally reflecting on your x-axis here. Reflection over your y-axis is when the negative sign is going to be inside of your radical, and it's going to be the opposite way, reflecting on your y-axis this time. Vertical stretch or shrink. Anything vertical is always going to be on the outside of your radical, multiplying with your square root or cubic root, so on. And in this case, when you have 1 over 7, it's going to get smaller. So it kind of like shrinks a little bit. It kind of like squeezes this way, kind of like taffy being pulled left to right. Horizontal stretch or shrink, that's going to be located in the inside of your radical. And if it's 7x, then it's going to stretch up higher. So it makes your radical raise up a little bit more. Okay. And so we're going to be using our transformations to describe what's being shown and then graphing out our transformations afterwards as well. So let's say that we have here f of x is equal to the square root of x, and we're given the transformation square root of x minus 3 plus 4. So let's start off first with our original function, which is f of x equaling to square root of x. We said that whenever we're using graphs for square roots, we like to use the numbers 0, 1, and 4. Those are always our key numbers to always start off with. So we have here 0, 1, 4. The square root of 0, that's just 0. Square root of 1 is 1. Square root of 4 is 2. Done. After we do that, I'm going to choose to deal with the inside first. So I'm going to do the transformation of a horizontal shift to the right by minus 3. And so I'll just write right here the description, because that's to describe it as well. We have a translation 3 to the right. And if I'm moving my graph to the right, that's like we're using the x-axis, because x-axis is where we're either moving to the left or to the right. So I'm going to be changing my x values here, which means that my 0, my 1, and my 4 on the left side is all going to be added by 3. 0 plus 3, 1 plus 3, 4 plus 3. That equals to 3, 4, and 7. And my y values still stay the same. Nothing changes from them. Then, after I do that, I'm going to deal with the plus 4 now on the outside. So my new function or translation will be x minus 3, and again we're adding 4. So in this case we're translating up 4 units. So translating 4 up. And if we're moving up, that means that we're focusing on our y-axis. So my x values are now going to stay the same as 3, 4, and 7. And my y values now are all going to be added up by 4. So add 4 to every single one of them. When you do that, you get 4, 5, and 6. And so we get our order pairs, 3 going up to 4, and 4 going all the way up to 5, 7 going all the way up to 6. And so that would be our final graph. Done. Cool. Let's try out another one. Let's say that we're trying to describe the function and then graph the following. We have here a cubic function. So again, with cubic functions, I want to use the numbers -8, -1, 0, 1, and 8. That's because a cubic root of -8 is -2. Cubic root of -1 is -1. Cubic root of 0 is 0. Cubic root of 1 is just 1. And cubic root of 8 is +2. Then from there, the only one that I see that's a transformation that's being made is that -8. So I'm going to do that together. I'm going to deal with the reflection sign and with our horizontal shrink or stretch at the same time. So right here, I'll write down that we have our cubic function, and I'm using the translation -8, where not only are we reflecting on the y-axis because it's in the inside of the radical, But we're also creating a horizontal shrink. Horizontal shrink. And if you remember about anything that's horizontal, we always have to remember one little thing, which is that we have to flip our number. So just a little bit of review, reminder about anything that's horizontal. Horizontal is that no matter what, if you have -8 as your number, it has to be flipped. So instead of it being -8/1, you need to flip it around so that it is 1/-8 instead, or vice versa, because of the fact that we have specifically a horizontal shrink or stretch. And so if I'm going to be dealing with a horizontal shrink or stretch, I always want to deal with my x values because we're stretching horizontally. So from here, I'm going to be multiplying -1/8 to every single number. 1/8, -1/8, -1/8. They're all multiplying with my numbers on the x value side. So multiplying to -8, multiply to -1, 0, 1, and 8. And that equals to 1/8, 0, -1/8, and the last one is -1. So when I get my graph, I get 1 going all the way down to -2. Then 1/8 going all the way down to -1. 0 going to 0. 1, -1/8 going all the way up to 1. And -1 going all the way up to 2. So it kind of looks like a very upside down or like flipped around S. Like that. And that would be my final answer. Cool. Okay, and the last one is understanding how to write a transform radical function. So let the graph of g be a horizontal shrink by a factor of 1/6, and it's followed by a translation 3 units to the left of the graph of f of x equaling to the cubic root of x. And we're supposed to write a rule for g. So again, you always want to start off with the first transformation that's told in the word problem. So let the graph be a horizontal shrink of a factor of 1/6. That's the first thing that we want to get rid of first. So I'll write right here, we're looking at horizontal shrink by 1/6. And again, reminder, horizontal means you got to flip your fraction. So instead of having 1/6, because it's horizontal, you have to flip it so that instead you get positive 6/1, which is just 6. So from our original graph, which is using the cubic root of x, that's going to change into being the cubic root of 6 times x. It's horizontal, so it has to be in the inside of the radical, not on the outside. The next transformation that's being made here is the translation. And it says here that it's a translation 3 units to the left. So if it's 3 units to the left, translation 3 to the left. Then that means that it's still on the inside of my radical. So starting off with our new function, cubic root of 6x, again, because it's in the inside and we're dealing with left and right, that means that we're still going to be dealing with inside of our radical. So instead, I'm going to write here cubic root of 6 times x, and it's going to be adding by 3 because we're always going with the opposite. And so from here, that's the last transformation. So I can just complete it by simplifying our function. So this becomes cubic root of 6x plus 18. That would be our final function here. So I'll use g of x. Cool. So hopefully this helped. Good luck.